Come on down. We're going to get started in just a few minutes. All righty. Please come sit in. You might have to squeeze forwards a bit on the front row. Thank you so much, everyone, for showing up, especially through the cold, through the snow, through the change of dates from last week. So I'm super happy that you're all here. Really, really appreciate you guys coming along. So this is Cloud Native London. We tweet on with the hashtag Cloud Native Lon. Cloud Native London is a strong, open, diverse developer community dedicated to the Cloud Native platform and technologies in London. My name's Cheryl. I'm on Twitter at @OyCheryl. I've been around the tech world for a little while, but most people know me from my time at CNCF. I'm now at ARM, sort of driving the adoption of ARM in the cloud through AWS Graviton and similar on Google Cloud and Azure. So if any of you are interested in playing with ARM stuff, do let me know. I'd love to chat about it. Tonight, we've got 3 talks for you. The first one from Charlie is called Using Spiffy and OPA to Authenticate and Authorize Workloads. Then we have Ben, who's going to tell us about the complexities of database caching at the edge. We will take a 15-minute break, at which point you can feel free to use bathrooms, go up and get more drinks, more pizza if there's any left. And then our third talk will be understanding the shift to custom Kubernetes resources. And then actually 8:30, we will wrap up. And if there's interest, we'll try and find a pub somewhere around here and we can keep chatting. I want to say a little thank you to tonight's sponsors who pay for pizza and drinks and make this all happen. So first up, we have Sysdig. Do we have any folks from Sysdig here who want to give a little shout out tonight? If not, then I will do it on their behalf. Give me 1 second. Okay, Sysdig. Sysdig is driving the standard for cloud and container security. With Sysdig, you can prioritize software vulnerabilities, detect and respond to threats, and manage cloud configurations, permissions, and compliance. Your teams get a single view of risk from source to run with no blind spots, no noise, and no black boxes. We have Styra, I believe. Yes. You want to say a couple words about Styra?
Yeah. Hey, everybody. Yeah, I'm Charlie. I'm from Styra. My colleague Greg is also here this evening. Yeah, we're the company behind OPA, the Open Policy Agent. So some of you may be using that and heard of that. It's a generic policy engine, and Styra has various products in that space. We've got a kind of control plane for OPAs, and we've also got now a new enterprise version or enterprise distribution of OPA that we're excited for people to try out as well. So yeah, both of them have got Load is the new OPA enterprise distribution that has a free preview, and DAS is a free tier that would be interested for people to try out as well. Yeah, if you're interested in OPA, come and chat to me, and you'll also hear a bit more about OPA in a bit.
Thank you, Charlie. And then the Just Eat takeaway, whose offices we're at. Stephen, I guess is not here, but thank you anyway to all of our sponsors for hosting us tonight. Okay, we're going to do a little bit of live polling. So if you have your phone on you, please go to this link, oyshower.com/p. You don't need to download anything. It's just a live poll. Apologies that there's no public Wi-Fi easily here. So you're going to have to use your mobile data. I'm going to ask you 2 questions about yourself, and then 3 questions about how you use cloud native from our speakers this evening. So this is oyshower.com/p. If you forget this link, there's a longer one displayed at the top. Okay, first question. Oh, people have already started answering. Is this your first time at Cloud Native London? So definitely not. I think you're pre-pandemic, like you came to Cloud Native London before the pandemic. So let's see, looks like 70% of folks are not first timers, so 30% first time. This is also going out to YouTube and to Twitch. So hello to the folks at home. I'll give you a few more seconds to figure this out. Hopefully you should just see the yes and no answers. Okay. Nice. Let's go to the second question. What's your job title? Just pick whatever's closest to what you do. Got options here: architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. Ooh, architects really pulling ahead today. 41% architects, some 24% mysterious others. Cool. Okay, looks like people figured out the live polling pretty quickly. So our first question, I think this one comes from you, Charlie. This is: for workload identities in my company, we use, the options are the cloud provider implementation, e.g. GKE workload identity, identity from a service mesh, e.g. Istio, a homegrown MTLS solution, Spiffy, or something else. I suppose the something else includes nothing, like we don't have identities, yeah? Or 40%, okay. I'll give another moment, and then I'm just wondering, Charlie, is this what you expected with this question?
Leaning Spiffy there was 25%, but I guess that was only when there was 4 votes. So yeah, this is kind of what I expected, to be honest. I actually maybe expected slightly more service mesh, but yeah, no. Come and chat to me about something else.
Yeah, what is this 40% something else? That's a big number. All right. Okay, hopefully people know more about Spiffy as well after your talk. Second question from Ben: is caching really as hard as naming? No, it's pretty straightforward. Yes, caching gets complex quickly. I have never used caching, educate me. Oh, yes, caching gets complex.
Educational pain.
Educational pain. Is it like this one you mean? The second option is the pain. Oh, okay. Not many people saying it's straightforward. Quite a few people saying they want to hear more. Ben, is this what you're hoping for?
It's a pretty good answer. So we've got a good blend of, we felt the pain, and then there's a pretty good mix of educate me. So hopefully it will be an interesting talk.
All right. Thank you, Ben. Okay. Third questions. Have you used Kubernetes controllers ever? Just a yes or no in this one. So this one, we have our third speaker joining virtually. Are you there? Want to unmute yourself and say hello? Let's see if I can. Oh. Ah. Are you there? Can you hear us? Okay, not getting you at the moment. That's okay. That's okay. We'll come back to this later. But looks like 71% have said yes, we have some experience with Kubernetes controllers, and 30% no. All right, thank you very much for joining in on this live poll. We're going to move on now. Okay, I need a selfie for the purposes of social media. Bear with me, just smile and wave your hand. at the back. I see you up here, up here, up here. Wait. Thank you. All right, and cloudnativelon.com, if you want to be up here speaking, or if you want to sponsor our next speaking slots are now January next year, January, February next year. So just plan ahead. You don't have to give the talk title until just before, but if you love to come and speak, then plan ahead for next year. You can also be our pizza and drink sponsors, or you can share your own events as well, or your own communities. And that is it. So I'm going to stop sharing here. And I'm going to welcome our first speaker, Charlie. Charlie, you want to come up and round of applause, please?
Okay, there's a annoying little window. I think the Zoom controls were there before, so I'll just go for it. Okay, yeah, so hello everybody, I'm Charlie, I work at Styra, and tonight I'm going to be talking about Spiffy and OPA, which are two Cloud Native Computing Foundation projects, and how you can use them to authenticate and authorize workloads. So yeah, first a little bit about me. I'm on the developer relations team at Styra. I spend quite a lot of time working on the OPA project as an open maintainer. I've also been contributing to the project for some number of years. And this talk is a combination of OPA and one of my other interests, Spiffy, which is more in line with what I was doing when I was working at JetStack. Yeah, so this talk is bringing the two together and showing you what I hope is an interesting vision to the future for how you might do authorization and authentication for workloads. So before we get started, I think we need to have some shared vernacular around what a workload is. So everybody here will have some idea, likely, but I'd like to share with you my definition. I think of a workload as a running instance of an application. That application might be a web server, it might be a batch job, it might be a CI job. That's what I think of when I think of as a workload. And workloads, they in a distributed system, they communicate with one another. They send messages to each other, they make calls against each other's APIs. And when they do that, they need to trust each other in some way. So we're all very familiar, at least with the kind of browser, web browser opening up, going to a website, you see the little padlock and you know what that trust, you know that there's a sort of trust, a root of trust that it has signed your certificate, has signed a certificate that has enabled your connection to that server to be secured. And workloads need a similar thing to what we need as human users using browsers, and they need to trust each other. So when I think of workload identity, I'm thinking of means for workloads to trust one another. And typically that's in both directions, both the server and client trusting each other. But perhaps as you saw from the question that we had at the beginning, a lot of people are doing something else. I'm not saying it's bad, but there are lots of different ways you can do workload identity. You can achieve workload identity, a system where different workloads trust one another. And some of them, I think, are better than others. And that's what I'm hoping that I'll give people an idea about how to assess what a good workload identity is. And I have some prior art here. I wrote a blog post when I was working at JetStack about what modern workload identity with Spiffy and trust domains looks like. And at the beginning of that post, I outlined what I think a good workload identity system has, what properties it has. And I explained how you can set that up with Spiffy and Cert Manager on Kubernetes. So if you're interested, I'll share the link at the end. The first idea or the first opinion I have about good workload identities is that they are short-lived and can be automatically rotated. And I feel like these two properties are kind of dependent on each other. Like, I want things to be so short-lived that automation is kind of required, really. Like, that you could employ a whole army of people to go around and keep short-lived credentials manually updated, but it wouldn't really make sense. And the reason that we want short-lived credentials in the first place is that if a credential were to be leaked or fall into the wrong hands for some reason, it should have a minimal impact. So it's only valid for as small a possible amount of time. So if they do have a credential, then they're not able to do too much with it, limiting the blast radius. So another thing that I think is important is if a credential is being transferred over the network, it shouldn't be possible to be intercepted and reused by a bad actor just by part of the normal flow of the use of that workload identity to establish trust. You can imagine the sharing of some secret information. If the channel were, if that secret information were to be sent over an unencrypted channel or intercepted by a man-in-the-middle attack, then that information would be lost and could be replayed or subject to a replay attack, which would be nice if our workload identities didn't have that vulnerability. I also think that good workload identity should be possible to carefully bound. So we should be able to say this workload identity should be trusted within a given domain or a given area of our system. Shouldn't be trusted everywhere, and it should be up to us how we control how that workload is trusted in different places. And finally, this is maybe slightly more of an unusual one, but I think it's important that the system is possible. It's possible that in the workload identity system, the server that's being invoked as part of some message passing scenario should know the identity of the caller. And I'll explain what I mean by that in a minute. So just a quick sort of rough grouping of some different workload identity systems that you could use. I mentioned briefly the concept of a shared secret. I like to think about the sort of secret common room that has a secret password, and if you say the secret password, then you're allowed in. Like in that example, that secret password isn't often short-lived because to communicate a new password to everybody takes some time. It's replayable because if you overhear someone going into the secret common room, then you can also get into the secret common room. And if the scope is unbounded, anybody who overhears it can use it, and it is known by the common room or whoever is granting you access to the common room. So at least it has that property. Publicly trusted certs and MTLS. So when I was at the cert manager stall last year at KubeCon in Valencia, we had a few people come up to us and they're like, oh, I'm getting my certificates from Let's Encrypt and I'm using them for my workloads. And we're running into all kinds of problems. And the kinds of problems that they were running into was that those certificates are hard to make short-lived or impossible to make short-lived. Public CAs won't mint use certs that are like the short duration that we're looking for. And they're also running into problems where they have their certificates are valid everywhere in their network, and they don't want that either. They also had loads of other problems to do with rate limiting and so on. So yeah, I don't think you should use publicly trusted certs for your private enterprise workload identity system. Service meshes. Service meshes are really good. They get us much further. And I've only put a cross against them because of that final idea of a good workload identity that I've highlighted here. And so this is probably the one that's closest to an opinion of mine, but I think it has some grounding in, I think it has some validity. So like last week, for example, we had two independent users who came into the Open Slack and they were using Open and Envoy Istio context. And they're like, I need to do data filtering on the response that's going back out of their application. They didn't want to have their application doing any authorization at all or any filtering. And it's kind of like, I worry that service mesh kind of encourages people into this bad way of, a potentially bad way of thinking where they want to, absolve an application from having any responsibility there. And I think that's great for some applications that don't have complicated authorization, don't have complicated data filtering. But I think service meshes sometimes make it harder for users to see that an application does actually need to own up and say, hey, look, I need to authorize this application. I need to authorize this client and do data filtering appropriately and so on. So yeah, what's the final solution? What's the thing that's going to tick all the boxes? Well, I think you can do it with Spiffy and Spiffy flavored MTLS. So when I say Spiffy flavored MTLS, what do I mean? So Spiffy stands for the Secure Production Identity Framework for Everyone. And it's a CNCF project that defines a certain identity format or two different identity formats. And it's a standard that I encourage to use, and then based on that standard, you can, in theory, do other things, which I'm hoping to show in this talk. So what it typically looks like, a use of Spiffy is two services talking to each other, and they have some Spiffy ID wrapped up in a Spiffy verifiable identity document, and they can communicate securely using those documents. So, and I'm going to be using the X509 or the certificate flavor of Spiffy. It also has a JWT implementation. So what do those certificates look like? I don't know if anybody here has ever dug into what sits inside an X509 cert, but I imagine some of you have at some point. And a Spiffy X509 cert looks a bit like this. I didn't manage to fit it all on the slide, but the important part is this URI in the subject alternative name extension. And it's a URI formatted value with the protocol Spiffy. And that's what Spiffy ID is. That's how we identify a workload. That's what a workload identity is. The workload is able to prove the identity because it has the private key of this certificate. And so this is meant to represent the domain in the URI is meant to represent a trust domain or some grouping. Remember, we were talking about how a workload's identity, we should be able to control where it's valid. That's a trust. That's the sort of Spiffy's terminology. That's a trust domain, a domain of trust. And then the path part of the URI is up to you how you use it. Typically, it might be, I've used foobar baz here rather unhelpfully, but it might be like production, Europe cluster 1, and then the name of the workload or something like that. Okay. So we've got Spiffy, we've got our workloads have got Spiffy IDs, and we have a load of services that need to talk to each other. And we're interested in how we can control what messages they can send to each other. So for the purposes of the rest of this talk, we're interested in making those decisions between message passing services in our infrastructure. And what is really good at making decisions, I don't know if anybody can see this one coming, but the Open Policy Agent is pretty good at this. It's designed to be a generic policy engine and designed to be invoked to make authorization requests as you need them. So let's quickly dig into what OPA does and how it works. So OPA is configured with a domain-specific language called Rego. It's a policy language, a declarative policy language, which if anybody has ever used Datalog, it's similar to that. It also feels a bit like SQL sometimes. It doesn't really feel like any of your imperative programming languages. Rego is a whole thing, a topic in itself, but this is an example policy that I'll try and quickly talk you through. It's in a package authorization. We're making use of a new keyword, but the main part is that we have a rule here. We have a rule which has a default value of false and an additional condition, which if the user's role is admin, then they will be allowed. So if I were to request that OPA tell me what the value of, or whether or not a request should be allowed with the data below, it's rather awkwardly in the middle, but this says their role is admin, they would be allowed. Alice at example.com. So how do I actually call OPA? How do I speak to an OPA instance? So OPA has a REST API, and the REST API looks a bit like this, or one of the endpoints looks a bit like this, where you can request based on the package name and the rule name, and you can post it some data, and OPA will do the evaluation for you and send you back a response. So it's a request response type interaction, and that's how we're going to be consulting and using OPA in this next section. So we've got Spiffy. We're using Spiffy IDs between our services to establish trust between those workloads. We've got OPA there. OPA is ready to make decisions as those messages are being passed. And so now's an opportunity to try and show you what this looks like or might look like in a real world scenario. So it will perhaps come as no surprise to some of you in the room that I've chosen an example scenario based on trains. I really like trains. And the best example I could come up with was this one, which is related to the seat reservation information. So when you get on a train, you look for your seat and it shows up on a little screen like that. So the train itself is aware of which seats are reserved. And I've never driven a train, and I have no idea how a system like this really works, but I invented one for the purpose of this talk. So I'm imagining that there is a train driver sitting in a train. The train or their train driver computer is connected to the local station via some wireless network, And then the local station is connected via some cable to the company HQ. And there's different, and I'm imagining that there are some services that run at the local station, and there are some services that run at company headquarters. I'm also, expecting that there are some computers involved. Exactly what they look like, you can make your own, imagine your own scenario. Getting on to something a little bit more boring, or perhaps more what we're used to seeing when we think about architectures. This is what we're going to be going through as in our demo. So we have a web client which is used by the train driver, and the web client is going to connect to the reservation service at the local station. So they're going to make a request and they're going to say, I'm this driver, I'm driving this train, give me the reservations that I need to set on my train. The reservation service is then going to consult the local OPA instance, which is running close to the reservation service workload in the local station cluster. And that OPA instance is going to say whether or not that request is allowed. If it is allowed, the reservation service is going to make another request to the booking service, which contains information about which seats are booked. And that booking service is in turn going to consult its local OPA and evaluate whether or not that request is allowed. And if it is all allowed, the information will be returned back to the driver and the train can be updated. In our scenario, we also have a demo. I've created a little demo configuration tool, which I'm going to use to poke the two different OPA instances and reconfigure them as we go through and try and get the system into a more desirable state where we're authorizing requests in the way that we want it to happen. The green lines and the red lines. The green lines represent connections that are secured using SPIFFE and where the services are talking to each other using SPIFFE in our demo. The web client is not using SPIFFE to talk to the reservation service, and my demo configuration tool is also not using SPIFFE to talk to the OPAs. That's kind of related to technical reasons of it running on my laptop as much as anything else, but also I need to make some changes to OPA to allow this bit to work. But the rest of it does work. I've already made the changes to allow this part where the services talk to OPA. I've made the changes already for that. However, they are unreleased. So what are the messages that are being sent? So in a bit more detail, we have the web client, which is making a request to the reservation service. It's giving the train service ID and the driver ID. The reservation service is then going to say to OPA, I've got this train and this driver, is it allowed? Between the reservation service and the booking service, it's going to make a request to an API endpoint called reservations with the train service ID and the driver ID. The booking service is going to say, I've got a given caller ID which is actually a SPIFFE ID, the driver, the train service, and the train services that I know about, and it's going to respond with some extra information to allow or deny the request. Okay, so I'm going to switch over and try and show you a demo. I don't know how to, there we go, okay. You'll be able to see this okay. This is a rather low budget UI that I have created in order to show you imagine, this is what I imagine the train driver might be using. So the train driver comes along and they enter in their driver ID and the train service that they're running. And then they click fetch. And when they click fetch, it automatically, what we're looking to get is a list of reservations that are needed for that train. And then I imagine that their laptop is smart enough to update the train. Okay, I'm going to zoom this in a bit because I think it might be a bit small. So we've got our first error message back. So so we're going to see various different error messages and various different things that go wrong, and then we're going to try and fix them with policy. That's how this demo is going to work. So this error message is coming from this OPA, and it's basically saying that this reservation service is not allowed to communicate with OPA because OPA is only accepting authenticated clients. So what we're going to need to do is we're going to use our demo configurator tool to update the OPA authorization policy. So at the moment, as you can see, it doesn't allow anything. And I'm going to make an update just now. Just give me a second. I need 2 hands to do this. So I'm going to update the policy to... I'm going to update the policy. So now the policy will... Gosh, it is quite tricky with these black lines across the screen, but hopefully it's sort of readable. The default is still to deny. However, if we manage to find and pass a valid Spiffy ID, we're going to allow the request through. So I'm going to refresh this page here. And now I'm seeing a different message. I'm seeing that the HQ OPA only accepts authenticated clients. So now I'm seeing a message that's actually come all the way from this OPA over here. So we've made progress, but we haven't really improved things very much. So I'm going to make some other changes. I think what we should really be doing is we should be checking that the reservation service, that only the reservation service is allowed to talk to the local station OPA. So I'm going to make that update now. I've got another version of these here's one I prepared earlier type things, but struggling with the copy paste. I will explain this one in just a second. Okay, so it looks I'm conscious that this might look slightly intimidating to begin with, but the reason I suppose is so that because I wanted to provide nice error messages explaining why a request was denied. But fundamentally, you can read this as there's an access control list where a given Spiffy ID, which in this case is the Station 1 reservation service, is allowed to talk to or allowed to call or invoke on the OPA instance this path, which is the reservations list deny rule. So now if it will still be allowed through, but we've added an extra check. And just to prove that it is in fact working, if I change this to something else, change it to allow only the den path, we'll see that the request is denied because it's not authorized to access the path that it's trying to call. So we do see that OPA is actually validating based on the path that's being called. But we've got another problem, I think, before we go on, which is that if I submit this with empty data, you can actually just see it in the tab there, train and driver are both unset, then I think we want to block that request as well at this point. We have enough information to say at this point that the request shouldn't be forwarded to the booking service. So we come back, and now we're going to make a change to our reservations list policy. So we're going to update the policy, and at the moment, it just denies. It never denies. It will always be false, and there will never be any denying going on. However, if we update it to say this, now if the input driver is empty or if the train is empty, you can read these as like ors between these different deny rules, they will be blocked. So if I can make this request again, I've got a message back saying the train must not be empty and the driver must not be empty either. So let's go back and let's put in some information again. Oops, fill this out properly. Slightly harder when you've only got one hand. So now we're back to this old message again. So we've done some validation in the local station. The request has been forwarded to the booking service, and now we're seeing a message from OPA at the booking service. So the message that we're seeing is that OPA only accepts authenticated clients. Our service is trying to authenticate itself, but the OPA in the HQ this time isn't supporting our Spiffy ID. So I'm going to make an update to that OPA authorization policy just now. Okay, so just to talk through this policy, it's very similar. It's a similar thing, but notice that this is the booking service within the cluster, the HQ cluster, and it's calling a similar endpoint. So let's see what happens. Let's see if that allows us to proceed with our demo. So it looks like our Spiffy ID or our workload with our Spiffy ID, the booking service, is not authorized to access this path. And it's trying to call not list deny, but call list option. And the reason it's calling list option is because the booking service has a slightly more intelligent OPA integration, where it's not just trying to allow or deny requests, it's actually getting some extra information from OPA to apply data filtering. And deliberately made the mistake not to include this in the ACL for the HQ OPA. So let's update this ACL to allow it to call the option rule as well. Apologies for the formatting, but hopefully you can understand that we're now allowing it to call another endpoint. So if I refresh this again, for the first time, we actually see some information. So this is something like what a successful result might be. But there are some problems here. One of them is immediately visible, that we've got the driver is seeing customer emails. So that seems bad. We would like that not to happen. The other thing that's a bit less obvious is that if I am driver 001 and I request a different train service, for example, train service 002, I get different information back, and it's kind of hard to read it, but this train service is actually driven by a different driver, driver number 2. And we're seeing a different set of reservations. So even though the driver and the train service don't match, we've still been given results from our service, which doesn't seem quite right. So let's see if we can fix some of these. So at the moment, we never deny, and we do set an option. It's called to do, and we set it to true. That's all we do. But first, let's see if we can fix the deny. So what we're going to do is we're going to do similar checks. I'm going to update it first, and then it appears at the top of the screen. I hadn't practiced this talk one-handed, but it's working all right so far. So we do the same checks. We also check that the driver is. We check if the driver is empty. We check if the train service is empty. Yeah, there's a duplicated check. We do that same check at the local station. For the purpose of this demo, I don't share policy, but you could imagine a scenario where you do share the same rules between lots of different OPAs, validating the same kinds of things in different places, different clients, like a JavaScript client, iOS client, or different services, whatever. But I've also added another rule, which is a slightly more interesting rule, which says, based on the train services that I've been provided and the train service I know that we're requesting, find the driver ID of that service, and if it matches the input driver, or if it doesn't match the input driver, then we need to deny the request, because we've got a request from a driver for a different train service that they're not driving. So we should, if we refresh this page now, we can see, if your eyesight's good enough, driver does not match the requested train service. Okay, well, at least the driver has now been told what they have to do, and that they're told not to be naughty, and they've got to go and look at their own train service again. Okay, so they're going to look at the train service that they're actually driving. So that's great. We've fixed one of the problems. We fixed the hidden problem, but we've still got this problem where we've got these customer emails. So it would be nice if we could write some policy to make them disappear, but only disappear for the driver, or disappear when a given service is calling the booking service. So I'm going to make an update to the policy again. And so now this is what our policy looks like now. Deny remains the same. I hope everybody can see this one at the bottom, but it's basically saying if option is called and the input caller is the station 1 reservation service, then we want to set show email to false. So going back to our architecture diagram, if we have a call from this service to this service, and the booking service has consulted OPA saying I'm getting a call from the reservation service, then make sure no emails are displayed. So if I refresh the page, it should say the email has been redacted by OPA. Obviously, in real UI, you might do something different, but that's what I did in order to show the demo. Okay, so that's the end of the demo. Thanks for bearing with me. So what have we seen here, and how long have we got? I still have about 2 minutes, I think. Might have to ask questions in the break. I've got 5 minutes. Okay, well, there may even be some time for some questions. In the demo, we've seen Spiffy IDs used to authorize requests to an OPA instance. So we know who is calling OPA, because obviously, if you could imagine a scenario where the result of, especially if you're trying to provide helpful error messages, you can imagine a scenario where your policy actually returns some sensitive information itself. And we certainly think of OPA as a security product, and it has some potentially sensitive information. So it's a good idea to authorize requests to OPA. And now with this demo, we've seen it's possible to do that using SPIFFE IDs or based on information available in a SPIFFE flavored MTLS connection. We've also seen that we can use OPA to enforce access. A lot of people probably knew that they could do that before they got here, but we had a little demo where we saw that OPA can be used in that way. Perhaps a slightly different example that maybe people hadn't considered before is that you can use OPA to trigger behavior and to trigger filtering of responses or control application behavior and standardize that across your estate. There's a bit of smoke and mirrors. There's actually supposed to be another bullet point on here, really. The first one is that this is meant to be running in a Kubernetes cluster, and it's meant to be using the cert manager CSI driver to provision the different services that are involved with SPIFFE IDs that are automatically rotated using cert manager. However, that's not what you've seen. You've seen something running on my laptop instead with SPIFFE ID or SPIFFE certificates that are valid for far longer than I would claim to recommend. But you get the idea. When I do this in the future, it will all be running on a kind cluster or something more advanced. The other bit of smoke, I suppose that actually, yes, and this is the next slide. I'll put it on the next slide instead. I did some work. I made some changes to OPA for this presentation. The part that I have changed is, if we jump back to this, is making this possible with SPIFFE. It wasn't possible to authorize, you could connect to OPA using a SPIFFE certificate, but to actually authorize based on information in a SPIFFE certificate, then that wasn't possible. So that was something that I changed in OPA. It's not released yet. It's actually not even merged, so don't try and use it. But stay tuned. I will try and get it done. There are some other bits that I'm keen to do. I would like to support this over SPIFFE as well. That's not currently possible. And I also think it would be nice to have some Rego functions to help people work with SPIFFE IDs. If you remember, I had a function to parse a SPIFFE ID, and the SPIFFE Go library has some good tools to help people say, is a SPIFFE ID in a given trust domain and things like that. I think that would be useful to add to Rego language. So yeah, that's it. If you scan, I don't think that QR code is going to scan because of the lines, but if you go to this URL minus the slides.pdf, that is where the QR code goes to. Some shout outs, the Jetstack blog that I wrote about this stuff and how you can use it with Cert Manager and things. There's no OPA in that blog post, but it's a good intro to using SPIFFE and provisioning SPIFFE certificates on Kubernetes. And also shout out to the Styra products, like the demo configurator tool that I'm using in my demo. That's what Styra DAS does, but like in a production way. And it does lots of other things too. So if you're getting started with Rego and OPA, you might actually find it's quite a good IDE for building and testing policies. And then the Styra Load, which is a new product you might be interested to try out if you're interested in using OPA in a kind of big data or enterprise type setting as well. So yeah, that's it. I'm not sure I have any time left, but if there is, we can do questions.
I'm going to take over screen
Okay.
sharing.
Yep.
We can take 1 minute for questions, I think.
Okay. Great. I think, oh yeah, sorry, yeah.
So you can use the same live polling services before, the same link, oilshell.com/p if you want to do questions. So we already have one question. There's multiple instances of the OPA service. How does the local OPA service maintain state of the authorization rules, and how are they kept?
Okay, yeah, I sort of brushed over that. Each OPA is basically polling the demo configurator tool, or in a more production use case, Styra DAS, to get the latest policy information. There's something called the Bundle Service API, which OPA uses to download new policy and data bundles. It's quite a featureful API, so I won't go into the details of it, but that's how it's working. I say polling. You are able to use HTTP long polling if you need kind of more sort of streaming type updates to OPA. But yeah, that's how it's working. And
one more question. How do you keep the consistency when there's more than one OPA instance instance running in the same cluster?
Okay, so that would be like making sure that every single OPA instance has precisely the same policy at precisely the same time, I presume. I think that's pretty tricky to do. Like in a distributed, everything is only ever really eventually consistent. I don't know how you would precisely make it sure that if you had to have a guarantee that the policy was only available at a certain time. Yeah, I don't know. You could have, and to check that the policy that was being evaluated was the right version. Yeah, I was trying. Yeah, I was thinking you'd have to. There's no OPAs don't talk to each other. There's no like sort of leader election and things like that. Greg's suggestion of using HTTP send is you could do that. You could say in your policy, you could use the Rego function to make an HTTP call to find out what the current version of the policy is. If you don't have the current version of the policy, you could just reject all requests. But that's not that nice. So yeah, like, but I think in theory, if things are working quickly, you should get updates sub-second. So yeah, I don't know. That's usually good enough.
All right. Thank you so much, Charlie. Another round of applause. And Ben. Okay. So we're going to use the same deal again for Ben's questions. So I'll stop this share for the moment. And Ben, whenever you're ready.
Just share. Okay, thanks everyone. So yeah, I'm going to be talking to you tonight about the complexities of database caching. So it may be a little higher level in the stack than some people are used to, but I think what's interesting is talking about the problems that we see with our customers, and also talking about how we built Polyscale and how that impacts cloud native. So a little bit about myself. I'm the CEO and founder of Polyscale. And my history, sort of last 20 years, has been in sales engineering, solutions architecture, working for predominantly, I guess back in the day, big data companies, and then into databases specifically. So I did some time at Elastic and a couple of other open source companies as well. And one thing that was sort of really evident in working in those businesses is that when you're considering databases and database architectures, the scaling challenges haven't got any simpler and easier over the years, in my opinion. So the database landscape itself has got kind of more and more fragmented. It hasn't really normalized into, a core set of databases that everyone's sort of settled on. And we're seeing basically more and more of the right tool for the right job. So what that leads to really is that scaling your database systems increases your complexity and cost. So if you're running, say, like a Postgres instance in a single location, that can scale up to a certain amount of transactions per second or requests per second. If you start to think about exceeding that, what are your options? And then when you start to think about multi-region, scaling that database into multiple regions to lower latency or to increase throughput, things get complex really quite quickly. And that's really where Polyscale was founded from. It's like, how easy can we make it to allow people to scale for performance and concurrency, and also lower geographic latency with their databases? So a lot of what we deal with is sort of in the application tier. We're making data-driven applications go faster. And there's a magic number in, people here may be familiar with that, but if somebody's visiting a web application and that renders in less than 100 milliseconds, that feels pretty instant to a human. That's a pretty good response time. So I don't know people's thoughts on sort of, data-driven apps that we use every day, like Uber and Google Docs and Facebook or whatever, but that's really the number that people are trying to get to. Can we render a page in less than 100 milliseconds? And that gets harder and harder depending on the complexity of your data-driven application. So scaling, presumably a lot of people in this room and watching remotely understand that scaling stateful cloud native data is hard. And there's lots of things that go into that around, geographic latency, cap theorem in general, and how you actually shard and distribute your data and query and access patterns. So just to give you a little bit of context around what we see at Polyscale with regards to the types of data-driven apps. So if you think about a web application specifically and that application tier, there's actually a huge number of options available nowadays to help people scale that tier. So it could be that you have a monolith application. You could run that in any of the hyperscalers in any location of your choice. And that's a really nice thing for developers and DevOps engineers, is we've got flexibility. We can easily move things, especially with Kubernetes, into different environments, different hosting providers. And what we're seeing nowadays is that multi-region applications are becoming quite common. So the classic example is I've got customers perhaps on the East Coast of the US, and I've also got customers in Europe. Why not have dual web applications running, one in either location? And it's now very easy to use a DNS service, Anycast, to route your users to the closest point of presence. So at that application tier, you've got a huge number of options. There's also lots of companies. Is anyone familiar with people like Vercel and Netlify, who are, with a simple git push, you can push your application out to multiple regions and multiple locations. And then finally, people are incorporating microservices into their applications more and more often. So we're seeing companies like Dino Deploy, again, Netlify, Cloudflare Workers, huge concurrency, parallel microservices that you can very effortlessly implement as a developer. But the caveat at the bottom of that is, as soon as you start bringing in data to that equation across multiple regions, or it becomes hard. Things get a lot more complex, and maintaining that low latency and high performance across multi-region then starts to gets difficult. So if we talk about database scaling as a whole, scaling. Let's say, for example, you have a Postgres cluster, and let's say that's overloaded, it's busy. I'm starting to get slowdowns on my queries. I'm getting complaints from the business that things aren't running fast enough. Typically you go to that sort of vertical scaling. If I'm using a cloud provider or a managed solution, I'll just increase my CPU and my RAM, and that will get you so far. The problem with that, however, is that it literally does get you so far. What happens when I reach the limitations? And you're running an always on service here typically, and therefore there's a lot of expense associated with this. So it's very easy to, very easy to end up with a very expensive database that may be being only utilized at certain points of the day. People often look at read replicas to help scale. So if you can offset your reads from your origin database, that can be a nice way to help you scale that load. So a very classic option is to separate your reads and your writes, depending on how what sort of workload you're dealing with. So let's say we put a read replica onto our origin. Again, that can get expensive because typically the size of that replica instance is identical to your origin instance. And the flip side of that as well is that once you've deployed that, you're still making queries against the database. So if those queries are inefficient, or you've got a huge data set, or you're missing indexes, all the classic stuff DBAs deal with every day, you still may not be solving that performance issue, even though you've separated out those workloads. And from a developer perspective, if you start using read replicas, you then have to think about, where do my reads go versus my writes? So at the application tier, if somebody's submitting content or they're updating content, those have to be routed to the origin server rather than the read replica. And database systems are getting better and better. There's client libraries to help you do that and make that job easier. But it's definitely something to be aware of. And then the final one, sort of on the read replicas, is, I don't know if anyone's experienced this, but there is typically, depending on your workload, there is a limitation to how many read replicas you can run. So we worked with a very large travel company who were running an origin, a primary database, 2 read replicas in different continents, and adding a third one caused a lot of slowdown to the entire system, because the read replicas are reading that write-ahead log. So you're adding more stress to your origin database. So it's a good option, but it can have limitations, again, depending on what type of workload you're dealing with. So as I mentioned already, you can, a classic way to do this is separate your reads and your writes. You can get scale if you're separating out those traffic types. People are turning to things like CDC, change data capture streams, so you can efficiently replicate out the changes on your database into external systems. And that's a great, there's books on these distributed systems where you can propagate out your changes from your database into things like Elasticsearch. Some sort of indexing system that can offset those reads and then leave your origin database to process your writes. And then finally, sort of getting that ACID compliance, as soon as you start thinking about distributed systems, that becomes a complex one. And there's some really cool systems coming out, Yugabyte DB, Cockroach DB, who are focused on having multi-write tenant applications. So I can have multi-write nodes globally, and they have, consistency models of your choosing. Again, it's there's a lot of options to get confused with, and there's a lot of configuration to be done, but it gives you the flexibility to design your system to meet your requirements. I think that's the best way of putting it. So these are some of the challenges we see with scaling your database systems. And for data-driven applications, caching can be used as an effective solution to some of the problems. So for slow query execution, for concurrency problems, and for solving that geo-latency problems, caching can be a good solution to that. It's not always the best solution, but it's a good option. So why is caching hard? Yeah, and there are many books and talks on this, and but I think if you start at the top, if we said to any application developer, okay, here's a relatively complex app, let's say an e-commerce system. We've got performance issues around slow queries. Where do we start? And I think really where you start is identifying which queries are the slow ones. If I'm running 50,000 unique SQL queries per day, which ones of those are really impacting my performance? And that could be things like, reading the slow logs. It could be things like real user monitoring. And hopefully that's not the case because your customers are then telling you things aren't good. But that's reality, right? That's where people end up. Stuff starts to slow down as it scales. So once you've identified kind of what are those top candidates, the next step is to, how long do we cache that data for? And that's a really hard question to answer depending on what you're doing with your application. So let's say I've got my e-commerce system. Do I just cache my products table for 10 minutes? Is that a good solution? And that comes down to a number of questions. It's like, well, how often are those product catalogs changing? How do I deal with stock and inventory? How do I deal with the recommendation systems? There's a whole bunch of related, content that may make this more complex. And then the next question is, well, if I set 10 minutes as my time to live, I'm caching data for 10 minutes. Is that right? Am I actually getting a decent hit rate on that? Is getting a 50% hit rate good enough? So these are kind of hard questions to answer and, very much use case dependent. So then the next question is, we've identified what we're going to cache. We've decided how long to cache it for. Then we need to decide when do we invalidate it? When do we actually decide, okay, my cache is stale. I'm serving stale content. My database is updated. And for a lot of use cases, again, that may be okay. So for a certain amount of time, serving stale data may be okay. And in other use cases, serving stale data may be very bad. So, example, let's take an online booking system. I'm booking hotel rooms. You cannot be serving stale data. So when a room is sold, that needs to be, the cache needs to be cleared and you need to be serving that origin data. So how you actually go about implementing that really comes down to what you're trying to solve, but at a code level, typically, you will be invalidating that cache. You'll be saying, okay, this event has occurred somewhere in my system. I'm going to go and clear that cache because I know I don't want to be serving stale data. And then on to the next part is like, okay, now I've got a cache running. Let's say I'm using something like Redis or Elasticache or whatever it may be, and I've got a 4 GB instance that I've allocated. When do I evict data? Typically people are confident using LRU strategies, and when we filled up that memory, we can start dropping stuff out the cache. But again, as sort of an engineer or someone implementing these types of systems, you've got to decide, is that okay? And what's the impact of that? If I start dropping stuff on the floor, I'm not getting that high hit rate that I need. and what's the impact to my end users? So stuff to think about, what happens when I actually run out of memory? Or are you paying for instances that are significantly higher than you actually need, but you've got to, cover that worst case situation? So where it gets really hard then is when you start thinking about multi-region. So I'm caching in one location, I'm caching in another location, I'm doing my sort of eviction, I'm clearing that cache when I need to, when I see updates, but I've also got to start pinging, the other location. And is that being eventually consistent? Okay. And you touched on what we're talking about with Charlie's work is that okay? Is that consistency model okay? Or do I need something more strict, which, there's a number of options out there as to how you solve that. But that can get complex, especially when you go to sort of many regions, 2, 3, 4, 5. And then finally, what about the long tail? And what I mean by the long tail is if we go back to our sort of complex application, our e-commerce application, and we're running 50,000 queries through there, and we're caching 5% of those. Is that okay? What about the other 90%? What about the queries that are less often used? Is it worth the developer time to go and start thinking about caching that as well and getting real optimum performance from your application? And again, typically most businesses say no. It is what it is, and we're okay with it being not as fast as it could be, because typically the overhead to doing that is a lot of time and complexity. So this is a quick kind of look at the development lifecycle of what we've just talked through. So if I was implementing caching into an application at the application tier, we go through all of those processes as we're sort of implementing this. So defining what the data structures are, how do we actually set that logic? How do we, we have to estimate what those time to live values are. We have to write the invalidation logic. We have to, have eviction policies. And then, I think everyone in this room is probably familiar with sort of the whole testing life cycle where you're adding a layer of complexity to your application and testing gets much, much harder. And then we move into the actual deployment and you're thinking about, okay, what's the sizing look like as we just talked through about the memory? How do we actually deploy this and how do we support observability so we can see what's happening in the system? And again, onto the multi-region side of things, that sort of, doubles the complexity there. So I don't want to sort of be, vendor selling application here, but I want to talk a little bit about Polyscale and kind of how we think about caching and how we, and also talk a lot about how we built Polyscale, because I think there's lessons learned here that are relevant for lots of parts of people's businesses. So at Polyscale, we're really focused on building a specific database cache that is plug and play. So we literally want you to be able to plug in a complex system, a complex application, and let the system start doing the caching for you. And all of that good stuff we just talked through, we want to be able to automate that fully. And the two problems we're focused on are query performance. So where you've got slow running queries, in our world, that's anything that executes in more than a millisecond. So if anything executes in more than a millisecond, once that's cached within Polyscale, we'll serve that sub-millisecond, that very, very large concurrency. And then the second thing is that Polyscale's cache can be put anywhere that runs Kubernetes or Docker, and therefore you can run that across multiple regions. So you can have a database instance in a single location, and you can have your cache in many other locations. So if you think back to that scaling of the application tier flexibility that developers have, you can just have a sidecar cache that goes with your application to then cache that database data locally. And I'll give you a quick demo a bit later and show you what that looks like. But really, at a high level, how does it work? We have what we call our application tier, anything that touches a database. So those could be web applications, serverless functions, or even things like Tableau or any BI tools that people are using on their desktop. If it makes a database connection, then it can connect through to Polyscale and be cached. So we're effectively, as I mentioned, a sidecar cache. So we sit between the application tier and your database. And Polyscale will actually inspect the traffic as it comes through and determine what to cache. And I'll talk a bit more about that in a moment. So we offer two solutions. So you can use our out-the-box edge network. So we have a cloud solution which is deployed into all the major hyperscalers and any other sort of smaller environments, GCP, Azure, DigitalOcean, Fly, anywhere you need a cache that runs Kubernetes, we can deploy that very quickly. And what that's useful for is just starting up and just using our service. So if I want to start caching in a specific location, it's very, very quick to do. We can literally deploy customers in sort of less than 30 minutes. And then secondly, you can run Polyscale on-premise. So you can have, there's a downloadable component, and I'm going to talk a bit more about that in a moment because it's built on Envoy, which I'm sure a lot of people here are familiar with. And that's run on-premise, so you can run that inside of your own private VPCs, and that anonymously connects back to our control plane, which I'll talk about now. So this is really the Polyscale architecture, and if we start at the bottom, the PCE components, the private cache endpoint, is effectively our proxy cache. Consider that where the data is actually stored, and that can live, as I said, on-premise. You can run that yourself. And that automatically connects back to our control plane that decides what to cache. And that's an anonymous connection. So the cool thing about that is all of the complexity around what to cache and for how long is all done externally. And all you're doing is hosting and managing the component that stores the data and manages the TCP connections in and out of your database. And then over to the right-hand side, you can see a couple of examples of our edge network where we run in AWS and GCP, as I mentioned before, and any other provider. And that's kind of an out-the-box, ever-growing network that we add to. And there's two tiers above that. So one is what we call the regional control plane. So that does the, the control and the AI management of the caching. And then at the very top there, you'll see that we have a global control plane that manages things like global invalidations. So if somebody comes in and says, hey, insert, update a record, set name equal to whatever, the cache will automatically remove that from the logic will automatically remove that from the cache in this location. Let's say this is London. It then sends a message back up to the global control plane that sends that out to all of the other endpoints and deletes the cache from everywhere else. So you get this eventually consistent model of real-time updates get deleted from the cache, and that's another piece of logic you don't have to build. So yeah, kind of a SaaS service that you can see on the right-hand side, and then the on-premise solution on the left-hand side. To talk a little bit how we built Polyscale, I think, as I mentioned, this sort of component here, the PCE, is built on top of Envoy. So if anyone's familiar with Envoy, we built our own sort of filters, and that's a C++ implementation, very low latency, and we've sort of utilized that for things like not having to build TLS and all that other good stuff that you don't really want to have to build. Nice and fast, zero copy buffering. There's a lot of benefits that we've sort of taken on board from that. So yeah, it's been a good experience. And we can run, as I say, we can run Envoy anywhere, using Kubernetes or Docker, which makes it nice and easy to deploy. So just talk about a couple of bits that make it, how does this actually work under the covers? And one of the things that we do is we're sort of wire protocol compatible with various databases. And why that's really nice is that it means you have to change nothing. So if you think about, I've been sold to by lots of vendors over the years that say, hey, migrate to my database or migrate to my client library and just change your queries and shard your data. That takes time and that gets complex. So what we're focused on is effectively Polyscale looks like a MySQL server. It looks like a Postgres server. It's wire protocol compatible. And what we do is we're sort of down at the layer 3, layer 4 TCP level, inspecting those packets to understand exactly what they're doing. Are they select queries? Can we cache them? Right, so DML, manipulation language, inserts, updates, and deletes simply pass through, and they go back to the origin database. So the nice thing about that is your transactionality doesn't change of your origin. And I've talked a bit about the invalidations and the fact we automate that. And the core of what we do is we are an AI-driven, we build statistical models on every single unique SQL query that comes through the platform. And from there, we can sort of solve those problems we talked about earlier, which is which queries do we cache? Which are the ones that we want to focus on? We set time to live values on those, and that's a constantly moving and changing thing. So based on the amount of requests coming in, based on the rate of change on the database, we'll be automatically adjusting those. Every time there's a query comes in, that gets adjusted. So that's kind of a job a human can't do very well, and therefore you can get very, very high hit rates because you're not guesstimating. For the essence of time, I'm going to skip over the last couple of bits, but as part of this, you sort of get observability as well, but I'd love to give you a really quick demo before we run out of time. And I'm going to do two just really quick demos. So firstly, I'm going to show you a quick web application view of the world. And what we've got here is a live application we call Playground that sits out of the US East, is hosted somewhere outside of our network. It's nothing to do with Polyscale, but it connects back to a database in Paris. And this is a public MySQL instance, and you can hit this and have a play. And all it does, if I run this test for 20 seconds, it's going to run a database query to the Paris database, and it's going to run those as fast as possible on a single database connection. And it's just going to time how long those queries take. And if I start that off, what you'll see is that, probably a bit small for the screen, but you'll see that anywhere between 500 milliseconds, 800, 200, 600, you get this sort of variable performance because we're sending a request over a decent sized distance, we're hitting the database, we're executing, and then we're bringing that content back. And on average, over 20 seconds, it's about 380 milliseconds to run those queries. So if you wanted to bring in Polyscale into this type of environment, there's two changes you need to make. One is that you update your application to use a different host name. So rather than pointing directly to your database, you point to Polyscale. And if you use psedge.global, that resolves to the closest point of presence. So of our edge network, it will resolve to the closest location to your application. And then secondly, we add a security key, and this is actually an augmentation of your database username. So Polyscale doesn't store your database username and password, so that's nothing we need, they just get sent through. What we do is, if this is your real database username, Polyscale, we augment that with a security key and a hyphen, and that just authenticates you against Polyscale. Now, if I run this, what will happen is we start caching that data at the local point of presence here, actually in New York. And what you'll see is we've obviously got some Wi-Fi latency here, but things are about 0, 1, 2, 3, 4 milliseconds, including network latency. That's not just execution time. And you get a very consistent performance. And you can see, we were doing sort of 2, 3 a second, and then, through Polyscale, we were doing about 1,000 a second. So we did 52 in that time period, and we did 21,000 via Polyscale. So that's really what we do. We plug and play, update your host name, add a security key, and you're good to go. And then for the last, just be very quick, how are we doing? We've got 2 minutes. Okay. I was going to show you another quick demo, but just to show you how to set up a cache really, really quickly, you can connect to Polyscale and get started with a live production database in a few minutes. So if I just create an account, I'll try and do this really quickly. I'm going to grab a host name one-handed and copy that. So I'm going to log into Polyscale, brand new account, and I'm just going to create a new cache. I'm going to give that a name. I'm going to select my database, which is MariaDB in this case. I'm going to put my real host name in, so that's where I'm pointing to, and that's on 3307. Once that's created, Polyscale gives me back my unique username. And as I said, it's sort of this key and then your own database username. So once that's done, you can just sort of log in with any MySQL compatible, MariaDB compatible address. So I can do, let's use MySQL. And for the host, I'm going to use psedge.global. And for the user, I'm going to copy my user key here, paste that in, and I'm going to put a hyphen and then my real database username, and then -p for a password. And put a password in and get that wrong, and then try again. Did that work? I think it's lost connectivity. I think we're struggling with Wi-Fi. Let's try again. There we go. So just to round up, so anything you would, we're now going through Polyscale, which, we haven't got time to run through it, but we get sort of full observability of that. So all of your queries get exposed here, and you can see where they're caching and all the rest of it. But yeah, so I'll pause there. Apologies for running a little over, but any questions, let me know. Okay.
And we've got just a couple of questions. So it'll take 2 minutes for these questions. Yeah. All right. Okay, the first question, we'll go from the bottom here. Great product and demo. Do you see similar problems in apps using NoSQL? Do you plan or already support NoSQL databases?
Yeah, great question. So the answer is yes, very much so. We've been going just over 2.5 years now. We've very much focused on transactional databases. So as you can see, MySQL, MS SQL Server, MariaDB, Postgres, and we're definitely moving into the NoSQL world. So things like MongoDB, as well as warehouses, Google BigQuery. So, taking a step back, we see using caching as kind of a fundamentally good way of distributing and querying data across geographies. So yeah, definitely. We don't support those right now, but definitely later this year, we're rolling out additional databases.
Next question. Can you separate DQL queries into I need to hit the database for the latest data and hitting the cache is okay categories?
So separate DQL data into I need to hit the DB for the latest data. So you're basically saying, can I force a miss, I think? Yeah. That's a good question. So through natively, no. What you can do is force a purge. I think it's a great feature where you would tag something. So taking a step back, if you Polyscale caches every query individually. So if you made a slight change to that query, it would force a miss. That could be something like adding a comment or select foo as bar and next time bar 1 or bar 2. That forces a new query and that would force a miss. But that requires some programmatic logic. But if that's something you wanted to build, then absolutely put a timestamp on something and yeah.
Okay, what are your keys for caching? Suppose I want top 100 instead of top 20 in my select. Would that be served by your cache?
Yeah, so the key is actually the SQL query itself. So as I just described, every unique individual SQL query is the key. We actually have an abstraction above that has cache intelligence based on similar queries without the parameters. But yeah, your top 10, your limit 10, limit 20 would be 2 unique different queries in Polyscale's world. But we learn from the previous intelligence. So if it's the same query with a different parameter, 10 or 20, you get a cache hit on the second request rather than the sort of third or fourth.
So this is the last question. You mentioned the cache endpoint will send a message to the global cache when a record is removed to remove the record from everywhere else. How do we avoid that cache endpoint being a single point of failure? What if that cache is down but others are up?
Yeah, good question. So on our SaaS platform, that's all sort of HAs built into it. So down at the each of the locations, let's say that location region goes down, GCP Paris has an outage, that automatically falls over to the next closest location. And that's the same for the control planes as well. So you may get routed slower, but you won't get downtime. So that's really the, sort of our SLAs are connectivity at all times, and then caching is the next layer down of performance. So it will be slower, but you won't get any downtime.
All right, amazing. A round of applause, please, for Ben. Okay, we're going to take a break now, come back at 8 o'clock. So there are loos in that corner on all floors. Feel free to go upstairs, grab yourself a drink, and come back for 8 o'clock. Thank you.
Hey everyone, this is Om from JFrog. I'm a software engineer at JFrog from R&D team India.
Oh, okay. Ooh. We are getting started now with our third and final talk of the evening. So Kel, are you there?
Yeah. Hello, I'm audible?
I think you might be, are you muted?
I'm audible?
Oh, we don't hear you.
Hello, I'm audible?
Okay, I see your microphone working. So
I'm audible? Hello? Hello, I'm audible?
Hello.
Hello?
Oh, I need Stephen. He might be upstairs to see what's going on with this. Hello. Okay.
Hello?
Hmm.
I'm audible?
Sorry, Cal. We're not
Hello?
getting your audio here.
Hello, I'm audible?
Hmm.
Hello?
Okay, let's try and. Oh yeah, if you can see you find Stephen upstairs, that would be great. He's try and grab him. Thank you so much. Apologies.
Hello? Hello?
Just talk amongst yourselves for a second. Hmm. It's all right. There's always something.
Hello?
Hmm.
Hello, I'm audible?
All right, let's try this one then. Okay.
Hello?
Cal, do you want to say something? See if we can hear
Hello?
you.
I'm audible? Hello?
Okay. I guess the chat, unfortunately we can't hear you.
Hello? Hello?
You couldn't find him? Okay.
Hello?
All right.
Hello?
I'll just send him a message and see if I can find.
I'm audible? Hello? Hello?
Okay. Oh,
Hello?
I guess you might have. I think Cal has dropped out and hopefully will come back in.
अरे आई शांत रहना. Hello?
Oh, we're still not hearing you. I'm so sorry about this.
Hello? Hello.
This worked absolutely perfectly the last time. So
Hello. I'm audible.
Okay. Anyone want to dial in? You can try. Okay. I guess I can try leaving the meeting.
Hello.
Don't know if I will. I don't know if this has the address to dial back in though. Let's see. Just make sure I have the copy invite link. Okay, let's try. All right, I'm going to leave this meeting and come back in. Done.